Good morning, student. Now, in our chapter number 12, Electromagnetic Induction, in this chapter, we have studied a new topic, generator. The generator, which is shown in figure. The basic construction of an electric generator is the same as that of a motor. The armature is turned by some external agency or torque. Has the conductor wire cut across the magnetic line of force and induced EMF, that is E is equal to capital B L V, is produced across the terminal of the commutator, which is proportional to omega, that is the speed of rotation of the armatures. In position, the conductor is moved upward across the line of force, induce maximum EMF. When the armature reaches in the position, then the conductor is moving parallel to the field and there is no induced EMF, that is E is equal to 0. At position, the same conductor moves down across the line of force and induced EMF or current is directed opposite to that of case first. The graph plotted between the current as the function of the time t show the sinusoidally varying a current. When a coil is rotating with constant angular velocity, that is omega, the angle between the magnetic field B and area vector A of the coil at instant time t is theta is equal to omega t. Then the flux phi b at any time can be written as phi of b is equal to b into a cos theta, that is phi of b is equal to b dot a cos omega t, where theta is equal to omega t is the angle between magnetic field vector B and the area vector A. From Faraday's law, the induced EMF generated by a rotating coil of n turns, then E is equal to minus n d phi b upon dt. Now E is equal to minus n d upon dt outside the bracket, then in bracket b dot a cos omega t. We can put the value of phi b. Then we have get plus or minus nb a omega is equal to plus or minus E0 and sin omega t is equal to plus or minus 1. That is E is equal to E0 sin omega t. Then we have get E is equal to E0 sin 2 pi ft, where f is the frequency of revolution of the coil, since the value of sin omega t varies between plus 1 and minus 1. The polarity of EMF changes with time. The EMF is maximum when the theta is equal to 90 degree and 270 degree. As the directions of induced current changes periodically, it is called as a alternating current, that is AC current. It is as shown in figure C. The frequency of AC is equal to the number of time per second the current changes from positive to negative and back again. The domestic electrical current varies at a frequency of 50 cycle per second. For the purpose of charging a storage battery, it is necessary to generate a steady or direct current, that is DC. The accumulator acts like a rapid switch which reverses the connections to the armatures at just the right time to match with the reversal in current. The reversal action accumulator can be used to generate pulsating DC as depicted in figure D. Now next are back EMF and back torque. The EMF can be generated in different way. In a battery, in piezoelectric crystal, in thermocouple, in a photoelectric cell, and in Van de Graaff generator. By Lenz's law, the induced EMF will tend to oppose the change which cause it. In present case, the cause is the current through the armature. Therefore, the induced EMF will tend to reduce the armature current. The induced EMF, which is unavoidable due to generator action in a motor, is called back EMF. Initially, when a motor is just starting up, its armature is not turning and hence it is not producing any back EMF. As the motor starts speeding up, the back electromotive force increases and armature current should be decreases. This explains the reason as to why the current through a motor is large in the beginning than when the motor is running at full speed. Now our next are induction and energy transfer. Consider a loop ABCD moving with constant velocity v in a constant magnetic field B as shown in figure A. A current I is induced in the loop in clockwise direction, and the loop segment being still in magnetic field experience a force F1, F2 and F3. An external force F is applied to overcome the magnetic force of equal magnitude but the acting in opposite direction. Then the rate of doing work on the loop is, we know power's definition, it's formula are P is equal to W upon T. Now the definition of power, the rate of change of work done with respect to the time. Therefore, P is equal to W upon T. We know work's definitions. Therefore, we can get the formula force multiplied by displacement with respect to the time T. Then we can get the equation P is equal to F into V. Now here V is the velocity and its particular definition, the rate of change of displacement with respect to the time. D upon dt is nothing but to the V. This is the power equation. P is equal to F into V. As the area within the magnetic field decreases, it decreases the magnetic flux linked with the moving loop. This induced current in the loop and it further gives rise to the force that oppose the pulling of the loop away from the magnetic field. Then the equation goes there, phi is equal to B dot A is equal to B dot L dot X. As X should be increases, the flux should be decreases. According to the Faraday's law, the magnitude of induced EMF mod of E is equal to d phi upon dt into the mod. Then E is equal to d upon dt. Now here put the value of phi is B L X here. Now we can get E is equal to BL into dx upon dt. Now E is equal to, we have get the equation BLV. dx upon dt is nothing but to the displacement with respect to time. It is also the velocity definition. Therefore, we can get the velocity V. The magnitude of induced current I can be written as I is equal to mod of E upon R. Therefore, it is equal to BLV. We can put the mod of E's value upon R. Therefore, R is the resistance of the loop. Due to the current I and magnetic field B, the force F2 and F3 being equal and opposite cancel each other. Therefore, it will be stated that vector F is equal to minus F1. They are cancelled. Therefore, here the remaining force F1 is directed opposite to the external force F. Then mod of F1 is equal to ILB. Now here the vector F1 mod of is equal to BLV upon RLB. Here BLV upon R is nothing but to the I's value. Therefore, mod of F1 vector is equal to B square L square V upon R. The rate of doing mechanical work, that is power, P is equal to vector F into velocity vector V. Then P is equal to B square L square V upon R into V. Then we can get the power equation P is equal to B square L square V square upon R. The rate of production of heat energy P is equal to I square R. Here P is equal to, we can put the I's value BLV upon R bracket square into R. Then P value is equal to B square L square V square upon R. Here the denominator R square into R, it gets cancelled, so remaining is R in denominator. Now comparing the rate of heat equation and mechanical work equation, we find that the rate of doing mechanical work is exactly same as the rate of production of heat energy in circuit or loop. Now our next topics are eddy currents. The relative motion between the conductor and magnetic field induce a current in the conductor plates. It is shown in figure. And opposing the force must be do work while moving the conductor with uniform velocity v. It is as shown in figure. The conduction electron making up the induced the current do not follow one path as they do with the loop, but swirl about within the plate as if they were caught in an eddy of water. Such a current is called an eddy current. The induced current in the conductor plate is responsible for transfer of the mechanical energy into heat energy. When a conducting plate is allowed to swing down like a pendulum through a magnetic field, a portion of its mechanical energy is transformed to heat energy. After several such sieving, is not a mechanical energy left with pendulum, and the converted heat energy is dissipated in the solid plate, making it warm. The eddy current can be reduced by discontinuity in the structures of conductor plate has dissipated in figure C. Reduces eddy current. These are the eddy current.